Welcome back to the combinations and permutations class. Previously, we introduced the concept of permutations and combinations, and we delved into the aspect of permutations, okay, under which we looked at uh, the fact that permutations has to do with order, okay, and arrangement. Okay, now we are going to look at combinations. Okay, combinations have to do with selection. And our formula for permutation was n r is equal to n factorial brackets n minus r factorial. This was our formula for permutation. Okay, now under combination, we are saying that if you have a set, given a set A that has 1 and 2, okay, given a set A that has 1 and 2 and set B that has don't mind my brackets, that has 2 and 1. Okay, so under permutation, A and B are one thing. Basically, A is equal to, sorry, under permutation, A and B are not equal to. Okay, regardless of them having the same characters inside 1 and 2, they are not equal because of the way they are ordered. Okay, A starts with 1 and ends with 2, while B starts with 2 and ends with B. Because of the difference in the order, it means the two sets are different. But for combination, we then say that order doesn't matter. As long as the characters in the particular sets are the same, the order doesn't matter, meaning A is equal to B. This is one thing. So if I have a word there, right, comprising of the three letters THE. So if I decide to rearrange this particular word into HET, okay, under permutation, this word, these letters, or the set of letters and this one, under permutation, they are two different. But under combination, this is one word, or this is one combination, basically. Okay, as long as they have the same characteristics, or the characters are the same. You have H here, you have H there, you have T there, you have T there, and you have E, you have E. All right. Having established that order doesn't matter, the only relevant then thing is the word selection. Okay, so we are just going to be dealing with selections under combination, and we exclude the idea of order. Okay, then what is the formula? So combination is equal to n factorial over brackets n minus r factorial r factorial. This is our formula. Okay, let's look at the question. This question says, Merv and Sons advertised to hire a financial analyst. The company has received applications from 10 candidates who seem to be equally qualified. The company manager has decided to call only 3 of these particular candidates for an interview. If she randomly selects 3 candidates from the 10, since all of them are equally qualified, how many total selections are possible? Okay, so you want to select 3 from 10. Now, just by that, we collect our data. We know that n then becomes 10, since 10 is representing the total number of items in a particular group. Okay, and R is the items to be selected from that group. And now we need to select 3 randomly from the 10. Having these particular variables, we use our formula to replace. So we will have 10, then 3 is equal to, our n there is 10 factorial divided by open brackets 10 minus 7 factorial, and okay, so here it's 3, right? R is 3. Whatever I was thinking in my head, I was rushing to the answer. Okay, how the brain sometimes calculates in advance. Okay, so we have 3 factorial here. So basically, we've just gotten these variables and replaced them in that particular formula of ours. Okay, then this will give us 10 factorial divided by 10 minus 3 is 7, right? Factorial, meaning there's a multiplication sign here. So we have 3 factorial. Okay, now we need to expand the factorials here. So basically 10 factorial means 10 multiplied by all the lower numbers. 9, 8, 7, 5, 6, 4, 3, 2, 1, right? And 7 the same going down. Now, if we have 10 multiplied by 9 multiplied by 8 multiplied by 7 factorial, meaning 7 also goes down. Okay, then our denominator here we have 7 factorial multiplied by 3 factorial. You realize that this will cancel out with this one, right? And what will remain is 10 multiplied by 9 multiplied by 8 divided by 3 multiplied by 2 multiplied by 1, since we are saying that also 3 factorial is 3 times 2 times 1, right? Then we are going to have 10 multiplied by 9 multiplied by 8 giving us 720 divided by 3 times 2 is 6 times 1 is 6. So we are going to divide that by 6. We are going to have our final answer as 120. So meaning you have 120 selections from the 10. So this is the number of selections you can have of 3 candidates from the 10. So basically, this is the general idea about combinations. Okay, so while we neglect order here on permutation, we actually, stick to the order because the order is important. Now, what is the application of these things we are dealing with? The application basically means the things that we can use this particular concept in the real life situations, right? So you realize that for the people that are usually involved in gambling and lottery, there is permutation and combinations there. So basically, when you see the what do you call the casino games rotating, so basically those different choices or options that are there are selections or are total number of possible selections, right? But you need to pick one out of those, right? So basically you use either combination or permutation to come up with those probabilities of possible outcomes. And lottery, you realize that okay, you are given, there are maybe 1,000 or 1,000,000 possible outcomes. Now, when you buy a ticket or you buy 5 tickets, okay, the chances of you winning is basically 5 out of the millions of different alternatives or options that are possible or possible outcomes, right? So you then get to use permutations and combinations in lottery. Then you realize that also in genetics and molecular biology, okay, for a father to transmit genes to a child, right? There is a transfer of genes there, and there is a combination of genes from the mother and the father, combining together to create a different, variety of genes altogether, right? Now, there are different possibilities of the genes, but then you get to have a particular mix, and that determines your phenotype and your genotype. right? So basically, it is also used in molecular biology and genetics. Okay, those are the few. And security, also, passwords on internet. You're trying to create your Gmail account or your iCloud. You are taught to put maybe a password with 8 characters, right? So if you realize that if you are talking about selecting 8 characters out of, take for instance, you are dealing with 24 letters, alphabetical letters. Do we have 24 or 22? I should assume 24. Okay, if you have 24 characters in your alphabet and you are supposed to select 8 of them, okay, in the and the order in this case matters. So basically what you are then going to have is a permutation arrangement. So you have a permutation of 24 as your total options you have, and you have 8 there as your selection. So now, based off this, if you have that permutation of that sort, what you are going to have, the different alternatives or the different ways you can arrange a password, then gives you, okay, let me just do that. It gives you, it's a big number. So you have 2.965 blah 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 times 10 raised to the power 10. Okay, so basically it's a million alternatives you have, right? It's a vast number. It's a big number. So for a hacker to be able to guess your password from these particular different ways you can make up your password is complicated. But if you have, you are putting a password of 3, 3 characters out of 6 characters, then you realize that you have a limited number. Then it's very possible for a hacker to guess. So the more options you have, the more complicated it is for a hacker to actually crack your password. So this is under cyber security and all. So this is where you get to use permutations and combinations. Now this is the way to calculate if either you don't have a calculator, or maybe you are not privileged with you are restricted. But then you realize that if you have a sharp calculator, when you press second function and you look at your above 5, okay, on your 5 figure, there is a combination symbol there, which is NCR. So basically you can use your calculator to actually calculate your combination or permutation. So it's very simple if you have a calculator. But for the purposes of knowing the formulas and all, this is how you get to calculate permutations and combinations. Hope you enjoyed the class.